In this lesson, we'll discuss learning target number 2, expressing the concentration of a solution using various methods. The concentration of a solution is defined as the amount of solute per quantity of solvent. Depending on what states the solute and the solvent are, different units can be used to describe the concentration. A mass to volume percentage, or M to V percent, is often used when you're dissolving a solid solute in a liquid solvent. It's calculated by taking the grams of the solute and divide it by the mils of the solution times 100. Notice this equation says mils of solution. That's the volume after you've finished mixing your ingredients together, not how much solvent you add. This is because the volume of the solvent will slightly change when you add your solute particles. In order to be more accurate, we use the volume of the solution after it's made. In solution chemistry, volumes are not additive. You can't add them together to find the total volume of your solution. For example, if you take 50 mils of alcohol and 50 mils of water and mix them together, you don't get 100 mils of solution. The alcohol will dissolve slightly in the solution and fit into the spaces in between the water molecules and give you something like 99.5 mils. To be more accurate, we always use the final volume of the solution after we make it. On the other hand, masses are always additive. If you take 5 grams of a solute and add it to 5 grams of a solvent, then you're going to end up with 10 grams of solution. An example of a solution communicated in an M to V percentage would be saline solution used to hydrate patients at a hospital. These are used for IVs. Typically, they're 5% M to V sodium chloride solutions. If you have a solid solute and solid solvent, concentration can be communicated in an M to M percentage. This is also used for gas dissolved in gases. This is because the volume of a gas can change depending on things like temperature and pressure. To calculate an M to M percentage, the grams of the solute are divided by the grams of the solution times 100. An example would be stainless steel is composed of iron as the solvent and 18% M to M chromium and 8% M to M nickel. If both your solute and solvents are liquids, a V to V percentage can be used. It's calculated using the mils of the solute divided by the mils of the solution and timesing it by 100. An example of this solution would be vinegar. It's a 5% acetic acid solution. Parts per million and parts per billion are used if you have very small amounts of solutes dissolved in your solvent. These are used for describing things like the toxins in an environmental sample or the amount of minerals in food. An example of a ppm would be figuring out how much sodium is in bottled water. Notice that these two concentration methods are not percentages. There's no times 100 at the end of their formulas. For ppm, or parts per million, you take the milligrams of solute and divide it by the kilograms of solution, where for ppbs, or parts per billion, you take the amount of solute expressed in micrograms and divide it by the kilograms in the solution. Now, if you have to convert into micrograms, there is 1,000 micrograms in 1 milligram. The unit of concentration that chemists use most often is molar concentration, represented by a capital C. It's calculated by taking the moles of solution divided by the liters of the solution. Mathematically, this equation is known as C equals N over V. In your assignment questions, you'll have some problems where you need to calculate in method 1 to 5. All you need to do is identify what way the question is expressing concentration, write down the formula for that method, sub in the numbers you're given, and rearrange for what you're missing. Because molar concentration contains moles, it can be linked to the other equations that we've already discussed in Unit 3. Particles equals moles times Avogadro's number, and mass equals moles times molar mass. Here we'll do some examples using molar concentration. In example 1, we're given the recipe of how a solution was made. 162.3 grams of salt is added to water to make 837 mils of a sodium chloride solution, and we're asked for the molar concentration. I can use the mass and the formula mass equals moles times molar mass to determine how many moles of salt was added. The molar mass of sodium chloride is 58.44 grams per mole. If I rearrange for little n, 2.7772 moles of salt were added. Now my calculator gave me a few more numbers, but I'll just write down the first 5. In order to find the molar concentration, I take the moles and divide by the volume of the solution in liters. Now there's 1,000 mils in a liter, so I'm going to divide by 0.837. This gives me a concentration of 3.32 moles per liter of NaCl when I take my sig digs into consideration. Now, instead of writing moles per liter as the unit, there is a short form. Now, it can be a little confusing because moles per liter is short formed as a capital M. Don't misunderstand this as being a molar mass. Molar mass is capital M if you see it in a math equation, but as a unit, capital M stands for moles per liter. Try out example number 2. Here we're asked to come up with a recipe to make a solution. Pause the video here until you get your answer. Because I'm given the concentration of the solution and the volume I want to make, I'm going to sub these into the equation C equals N over V. C is 0.250 moles per liter, and I can solve for little n representing moles. I need to convert my 60.0 mils into liters. It becomes 0.0600. I rearrange for little n, I get 0.015. Now my calculator cuts the number off there, but if you notice, I should still carry on with 3 sig digs. So I add a 0 onto the end of my number. The question asks me what mass of NaOH I need. So I'm going to use the equation mass equals moles times molar mass. I need 0.0150 moles, and the molar mass of sodium hydroxide is 40.0 0.00 grams per mole. That means I need 0.600 grams of sodium hydroxide solid in order to make my solution. I need to include 3 sigdigs in my answer. Try out the expressing concentration questions listed on your Unit 4 assignment cover sheet. Make sure to show full solutions with units and proper sigdigs.